Hello class, welcome to today's lesson, which is subtopic 1.6, fundamental kinematic quantities. Don't let this word scare you. Kinematic just means related to motion. So basically we can translate this into fundamental quantities related to motion. That's what kinematic means, more or less. So don't worry too much about this word. Okay, let's start, guys. We're going to take a look at 9 fundamental quantities, most of which you already have a good idea of what they are. For example, movement or motion, we know what that is. We know what distance is, displacement, speed. We have a very good idea of what these things mean. We only need to formalize the concepts. What that means is make them more precise than the way we use them in everyday life. That's basically what it means. So let's start, guys. The first kinematic quantity is movement, or also known as motion, right? So what is motion? I prefer the word motion. Motion is the change of position of a body. And that's very simply explained in the following way. Suppose you have a street, and I don't know, you have a tree over here, and you have a person. There you go. So how can you say, well, when can you say that this person moves? When you observe that he goes from one position, for example, I don't know, let's say 2 meters from the tree, and if you observe that at a time later, the person is further away from the tree, then you can say that this person has moved. It's basically that. Why? Because this person has changed the position. With respect to what? In this case, with respect to the tree. Okay, that's basically what it means. Now, suppose you have no frame of reference or point of reference. You just have a person right there. And I don't know, all the universe around this person is just white. Like in the movie Matrix. I don't know if you have seen that movie. It's a pretty good movie. Take a look at it. So suppose that you have no point of reference by means of which you can measure the position of this person. Then you cannot actually say that this person moves in that space because you have no point of reference. Whenever something moves from one point to the other, you have to have a point of reference, whether a car, I don't know, any other object, in reference to which you can measure the distance of that object that is supposedly moving. Okay, in this case, this person went from this position to this other position with respect to this object, and therefore you can say that this person has changed position. But if you lack any point of reference, you cannot actually talk about motion. That is a very philosophical concept. Try to understand it. Okay, let's move on. Distance, also known sometimes as distance traveled. What is distance traveled? Distance is the overall length of the trajectory of a body as it moves. So for example, let's suppose you have your home right there and your dog begins right there outside your house, and your dog is gonna take a walk and it's gonna follow this path. That's it, and it's gonna end right there. So this is the initial point. This is the final point of this line that we call the trajectory, la trayectoria. This is the trajectory of your moving object. Okay, so what is the distance traveled of this dog? It's basically all this length. This is the trajectory, and if you were able to actually measure all of this length of the trajectory, then that would be the distance traveled. Distance traveled. And as you may suppose by now, this distance is measured in units of length. Okay, for example, meters or kilometers or centimeters, whatever. Okay, so that is the distance, guys. It's just the length of the trajectory of a body as it moves. Next concept, the concept of displacement. Many people think that distance and displacement are the same thing. They're not. What is displacement? It is a little more complex than distance. Displacement is the length of the rectilinear segment joining the initial point and the final point in a trajectory. So let me go back to that example that I just showed you, the one about the dog. You have your home, there is your dog, and your dog is gonna take a walk from this initial point to this final point. And it's gonna stop right there, let's suppose. Okay, so clearly the dog doesn't go from the initial point to the final point over a straight line. He's gonna do this curvy thing, this trajectory. Okay, fine. Now, if you actually drew a rectilinear segment from I to F, like in this way, okay, like in other words, if you only care about the initial and the final points, like the overall motion, you don't really care about the details, because the dog really is doing this. He's going over this path, over this trajectory, right? But let's suppose you don't care about that. You only care about the initial and the final point. You draw a straight line joining the initial point with the final point, and you measured the length of this rectilinear segment joining I with F. The length of this. The length of this, guys, would be the displacement of the dog. This is the displacement, and in red I'm gonna draw the distance traveled. All of this is the distance traveled. If you measure all of this red line, that would be the distance traveled, and if you measure the blue line, that would be the displacement. So as you can observe by this drawing, we almost always, well, yeah, always we have that the distance traveled is going to be greater than the displacement, always. And only in one specific case they're going to be equal, when your object, let's assume another dog. Let's suppose this dog moves perfectly on a straight line from initial point to final point. Then, since the dog is moving perfectly on a rectilinear line, then in this case, and this case only, the displacement would be equal to the distance traveled. Only in this case. But for any other case, the displacement and the distance, we will always have that the distance is greater than the displacement, always. Okay, that is displacement. Number 4, speed. Speed is how fast an object moves, regardless of the direction it's moving. It is measured in units of length over time. So again, we have an idea of what speed is. It's just how fast we're going. And we usually say that, I don't know, we have a speed of 5 kilometers per hour. What does this mean? Well, it means that every hour we travel 5 kilometers. That's what it means. It's that simple. So what is the difference between speed and this other thing that I'm going to comment in a moment, velocity? Again, these two things, guys, are often confused, but they're not the same. Speed is just how fast an object is moving, just how fast, regardless of the direction of the motion. You don't really care about the direction when you consider speed. For example, if a car, I'm gonna draw very simple cars. If a car is moving in this direction at let's say 50 kilometers per hour, and another car is moving in the opposite direction at this speed, you can see that the speeds are the same even though the directions are opposite. The direction of motion in this case is towards the right. The direction of motion in this case is towards the left. But in both cases, we say that the speed is 50 kilometers per hour. This is what we would say. In other words, when you use this word speed, you don't really care about the direction of motion. You don't care about direction, just how fast the object is moving. And that's what differentiates this quantity from velocity. Velocity is a little more complex. Velocity is this. Velocity is how fast an object is moving, including the direction it's going. It is measured in units of length over time and should have a direction. Let me explain to you what I mean by this, using the same example of the cars. So you have this car moving in this direction at a speed of 50 kilometers per hour. And let's assume that you have this car moving in this other direction at the same speed, 50 kilometers per hour. Let's call this car A, let's call this car B, and let's draw a point of reference. This is north, this is south, this is east, and this is west. Okay, so if I asked you, what is the velocity of car A? What you have to say is this. The velocity of car A, you can actually make these abbreviations, very nice. The velocity of car A will be 50 kilometers per hour, okay? And then you have to, look, you have to include the direction of motion. So it's not enough to say this. It's not enough to say the velocity of the car A is 50 kilometers per hour. That is incomplete. Incomplete. What we should add is something like this, towards the east, right? Because this car is moving in that direction, which is the direction of east. We can say towards the east, or we can just say this, look, 50 kilometers per hour east. That's it. That's it. As long as you mention somehow the direction, you can say towards the east, or just write the E for east. I don't know. You can have some freedom. Then this is a complete answer. This is the velocity of car A. And thus, the velocity for car B is going to be 50 kilometers per hour west, or to the west, or towards the west. You can have some freedom in how you say it. Okay, you have some flexibility, but you need to include the direction. Velocity includes direction, speed doesn't. So they're not the same thing, guys. Speed and velocity are not the same. Do not confuse them. Okay, what about acceleration now? Acceleration is how fast the velocity of an object is changing. It is measured in units of velocity over time. What does this mean? For example, when you get into your car, okay, this is the highway, and as you may know by now, I hope you have driven or you have observed how somebody drives. You have the gas pedal, okay, and when you step on that gas pedal, this thing is gonna accelerate. The car will accelerate. What does that mean? It means that's gonna change its velocity. That's what it means. It's gonna go from perhaps from being at rest at 0 kilometers per hour when you are in your garage or something, and it's gonna accelerate, which means that the car will pick up velocity. Maybe at this point we'll have a velocity of 10 kilometers per hour, and maybe at this other point the car will have a velocity of 20 kilometers per hour, etc., etc. So basically, acceleration is that your car is changing the velocity. That's what it is. Now, suppose that you're already driving, you're already in the highway, and this is the highway. Not very nice. Okay, and suppose that you observe your speedometer, el rapidímetro, which is this thing on the car. Okay, and then you have the indicator, which is this needle, and you have it pointing at 80 kilometers per hour. Okay, right there, and you observe that this thing doesn't change. Okay, you have it, you have your foot on the pedal in such a way that this measurement doesn't change. Then is your car accelerating at those moments? No, because if the velocity is not changing, you're not accelerating. For acceleration to occur, you have to have a velocity changing, basically. Okay, let's keep going. Number 7, mass. What about mass? Mass is how much matter there is in a body. But pay attention to this disclaimer that I'm pointing out. This is just a primitive definition. This is not a good definition, guys, at all. This thing that I'm telling you right now is not a good definition. I will explain to you why later in the stage number 2, in which we're gonna get over this, all of these quantities. We're gonna study them in depth, and you will see how this thing is not a good definition in science. I know that you were told this in junior high. This is wrong. This is wrong in science. Okay, so just keep that in mind. I will tell you later what mass really is. And let's just, for the moment, let's just say that it is measured in kilograms. That's all we need to know for now. Now, force. What is force? Force is any action exerted. I want you to get used to this word because I'm gonna be using it a lot. Exert, exert. It's basically impart. When I exert a force on you, I am imparting or applying a force on you. That's what this word means. It's not very complicated. So force is any action exerted or imparted on a body which will accelerate it. It is measured in newtons. For example, one more time, let me give you another example. Let's now talk about a rocket, or a spaceship or something. Okay, so suppose at some point in the trajectory of this spaceship, the spaceship is going at, let's suppose, 200 kilometers per hour. Let's suppose. Okay, and then a little later, you observe that this same object has a different velocity, 200 kilometers, 250 kilometers per hour at this point. This is at point A, this is at point B in the trajectory of the spaceship. So what can we observe? We observe that the spaceship changed velocity from this much to this much. That means clearly that the spaceship accelerated, right? Because it changed velocity. Whenever we change velocity, we are accelerating. Fine. Now you may ask yourself, what caused that acceleration? How could this spaceship go from this velocity to a greater one? Well, what happened was that there was a force applied on the spaceship. In this case, what is that force? Well, it is the force applied on the spaceship by all the gases that are being expelled. You see? I mean, I'm pretty sure you have observed one of those things at Cape Canaveral. You know, when they launch the spaceships, that is what's happening. All these gases that are being expelled from the turbines and all that stuff are applying a force on the spaceship, and therefore the spaceship will accelerate. That's basically what it is. If I have a table and I have a cup of coffee or whatever, and if the coffee is at rest, if this cup is at rest, and I go and I come and I push it with my hands, I will observe that this cup will change its velocity from 0 kilometers per hour or meters per second, whatever, to some other velocity, okay, when this thing is moving, okay, from 0 meters per second to, let's say, 5 meters per second. And what that tells me is that this body experienced a force. In this case, what caused this force? Well, my hand, in this case, you see. So basically, when you apply a force on an object, you're gonna accelerate it. That's the conclusion, or the consequence of applying a force onto something. You will accelerate that something. And finally, weight. Many people also confuse mass with weight, and we're gonna see in detail why these things are not the same in the second stage. This is just basically like a primer, guys. All of these things that I'm telling you right now is just the introduction to these ideas, only the introduction. We're gonna analyze these things in depth in the next stage. So what is weight, and how is weight different from mass? Well, weight is the force that a planet applies on objects on or near its surface. For example, for us, planet Earth, you have planet Earth, and planet Earth is going to apply a force called weight upon every single object on its surface. So you are right here, right now. And what makes you stick to the surface of the planet? Well, it's a force that the planet applies on you and your desk and the apple on the desk, every single thing that is on the surface or even close to the surface. It doesn't have to be really on the surface. For example, if I have an airplane right here flying above the surface, also this airplane is being subjected to the force of gravity from the earth, and we call that force the weight of these objects. For example, this force that is being applied on you right now is called your weight. The force that the earth applies on this airplane right now is called the weight of the airplane, etc. And obviously that force is always directed towards the center of the earth, towards the center of the earth. For another person on this part of the hemisphere, that force will be directed in this direction, and that's going to be her weight, etc., etc. Okay, so weight is a force, and mass is not the same as weight. One more time, we're going to understand why they're not the same in the second stage in very much detail. So this is just a very primitive primer onto these concepts, guys. I'm going to ask you some questions in a moment and see how well you understood them. But that's it. Just for starters, these are what these quantities mean. So let me go back at you.